Hello. This is Alfred. Today we will be looking at part 2 of the generate and read pulse signal. So as you can see, we have a square wave signal here, and this is closer to 90% duty cycle. We will look at how we can increase and decrease our duty cycle, as well as start the signal at a low state. So we'll start off low and go high, then low and high. Make sense? So we will look at that. So the reason why we are looking at increasing or decreasing the duty cycle is because of this comment. So if you look at, if I could find the comment. Alright, so right here. So Nadia was asking if we could change the duty cycle, and also be able to go from low to high, somewhere there. Let me see if I could find it. High and low and down. Well, I'm not able to find it. Let me not waste our time here. But the reason why I'm showing this is because if you have questions like this, ask the question on the comment section. I will be more than happy to look into it, and I'll be more than happy to show it if I know how to do it. Okay, so how do we do this? Obviously we can definitely do it over the code. So let's go ahead and minimize this, and here is the Arduino code now. Nothing much have changed, apart from nothing have really changed from the prior video, apart from this line of code, and I added this line of code just for something I will show you in a little bit. So let's see. So to change your duty cycle, essentially your Arduino is reading all this configuration of square wave. So this is where the configuration of your square wave is, just so you know. So here, this is where we initialize the wave, the square wave, or the type of wave that we want to generate. So if you come over here, I know I did not mention that the last video. So this is our index number 0, this is index number 1, this is, which is a triangle wave, index number 2, which is a sawtooth wave, and this is index number 3, which is a square wave. So our code is only interested in the square wave. So whatever we have here, that will be what our code will be outputting right here. So that's what our code will be outputting in our digital analog converter pin number 0. Does that make sense? So right here, as you can see, I have this changed. So this is a hexadecimal value, and based on your duty cycle, you can have this equal, your high equal, and also your low equal. So this is your low, this is 0, 0 count ADC, and this is FFF. So let me say that again. So this is FFF hexadecimal value, and when you convert this FFF hexadecimal value to a decimal number, so right now this is a hexadecimal value, right? So if you convert it to a decimal value, so that's 4095, and that's a representation of a 12 bits ADC for the Arduino Due. So, oh yeah, I did make this note here. So Arduino Due is capable for 12-bit ADC. So that's essentially what we are giving it, the high side, which converts to the highest voltage from the Arduino. So essentially what I did here from our previous, so if I hit Ctrl Z, 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 Ctrl Z, 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 right here. So this is what we had before. We had an equal amount of 0 or, or off. We had an equal amount of off time and on time, which is essentially 50% duty cycle. So we have about 1, 2, 3, 4, 5, 6, and we also have 6, 6 on the off time. This is also equal 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So essentially, to increase your duty cycle, obviously we want to make our on time higher in number. So essentially copy this. So we copied 2 lines, so we want to put 2 lines here and paste it. So now we will have a slightly higher than 50% duty cycle. So now that we have made this change, go ahead and save it. Then go back to your code and upload it. Sometimes it does error out. Here we go. Alright, so now let's go ahead and monitor it. Here we go. So as you can see, we have a longer on time and we have a shorter off time, which is essentially an increased duty cycle. Definitely it's probably in the neighborhood of maybe 60, 70, 80 percent duty cycle. You will have to use an oscilloscope to monitor it to determine what your duty cycle is. So yeah, but now let's go ahead and tackle the next problem. The next problem is, well, it's not a problem, but it's just a next change. The next change is that we want our start to start from off, then on, off, on, off, on. So right now we are starting it high and going low. So the reason why that is because our on in the first line of code for our signal. So this is our signal essentially. So we have on, we are starting from on, then off, right? So this is 0 and this is the highest, which is 4. I believe this is 4095 ADC count. So this is a 12-bit ADC. What we want to do, yes, you guessed it, we want to copy this off time, or sorry, cut it, then put it in the first line. Then don't forget to add your comma here and remove the last comma here. Ooh, too much. Okay, then you are done. That's it. Now you will start low and go high, then repeat it. So remember, this code always, whenever it reaches the maximum number of sample, it zeroes it out and you will start afresh to inject the signal. So that's essentially it. And now you want to upload it. Let's go ahead and hover on the plotter so that we can see it right away. We want to open up the plotter as soon as it is done uploading. All right, here we go. Here you see it started low and goes high, started low, then goes high. So that's essentially it. I believe this is everything that I had to share today. And yeah, if you have any questions, go on the comment section. Please throw it at me, and I'll be more than happy to take a look. If it is something that I'm able to do, I will be happy to make a video about it and show you. And hope this was helpful. If you like this type of video, please go ahead and subscribe, like, and let me know what you think about it. Thank you. Bye bye.